Okay, so let's continue our solution here. So according to this equation, our IO of S is equal to S multiplied by minus 1666.6 divided by 100 and over S squared plus 2S plus 5. So this is what I'm supposed to solve, and in order to solve this, the first step is PFE, and then the next step is Laplace inverse. Okay, let me redraw everything here, and then I'm going to show you the PFE. In order to start PFE, what we need to know is the roots of our denominator. If you find the roots of your denominator, you're going to see that you are having a set or a pair of complex conjugate, and those are equal to, so your roots are -1 plus minus j2, which means your factors in denominator are s plus 1 plus j2 and s plus 1 minus j2, and then you have minus 16.66 s in your numerator. So it means that your partial fraction will be in form of, let's say, a over s plus 1 plus j2 plus a conjugate over s plus 1 minus j2. So it's the only thing you need to solve is this a, because the other coefficient is just a complex conjugate of what you're finding for your a. How we can find our a? In order to find a, what you need to do is that here you have IO of s. So you have to multiply your IO of s by the denominator of the coefficient you're looking for. So by s plus 1 plus j2, and then you have to evaluate this at the root of denominator, which is -1 minus j2. So this is going to be your a. So it means that you have to forget about this term, because here it cancels out this one, and then you're going to have minus 16.66 multiplied by your s, which is -1 minus j2 divided by s, which is -1 minus j2 plus 1 minus j2, in which -1 and -1 cancel out, and you have to do the calculation, and then you're going to have, so a is equal to 9.3 with an angle of 154. Okay, now that we have a, it means that we are done with PFE, because we have calculated our a and we know what is the conjugate of a, so we have both numerator. Now let's see how we can do the next step, which is the Laplace inverse transform. So for Laplace inverse transform, whenever you have something in this form, you have, for example, k1 over s plus a plus j omega plus k1 conjugate over s plus a minus j omega, then you can say that the Laplace inverse in time domain for this function is going to be 2 multiplied by the magnitude of k1 multiplied by e to minus at multiplied by cosine of omega t plus the angle of this k1. So what we need to know here is we need to know what is this numerator, what is a, what is the constant, the real part of our constant roots in denominator, and what is the imaginary part. Let's see what are they. Basically the k that we are looking for is this a. So the magnitude of this k1 or whatever constant or magnitude of a is equal to 9.3, and the angle of k1 is equal to 154. And then for a and j omega, let's go back to the previous slide. So what we have for A is 1, and what we have for omega is 2. Let me write them here. So our A is equal to 1, and our omega is equal to 2. So now I can describe my IO of t. My IO of t is 2 multiplied by 9.3 e to the power of minus t cosine of 2t plus 154 degree multiplied by u of t. Don't forget u of t, because that basically show you that you have a switch. So this is our answer in time domain for the current of capacitor, which is our IO of t.